Okay, this lecture covers routing protocols. The purpose of routing protocols is to get packets to a remote machine that is in a different network. Now, one way to look at the type of routing protocol or the type of routing we're doing is what is intra-domain routing versus inter-domain. And as those prefixes imply, intra-domain deals with routing within a domain, which will often be a network or collection of networks, like within a business or a school. Interdomain routing deals with routing within your domain as well as domains outside of your domain. Routing protocols use something called metrics to make their decisions. And basically, metrics determine the best path for a packet. Sometimes it's one metric, sometimes it's a calculation that creates the metric value that we're going to be using. Metrics are things like hop count, which will be how many routers does it have to go through to make it to the destination. Link state is the link or the port and the network connected to the port up or down. How reliable is the path? Maybe how much packet loss are you having? What is the speed of the connection? You know, is it 100 megabit? Is it gig? Is it 10 gig? How busy or load is another metric. Latency is another metric. And then sometimes a decision is made on the maximum transmission unit. A lot of times this is 1500 for an Ethernet frame, but if you have a high-speed connection, that MTU may be higher. So there are different protocols that we're going to talk about. There are more than these, but for our discussion, these will suffice. The first is one of the original routing protocols, which is RIP. This was created, or at least standardized, in 1988. It is something called a distance vector protocol. So how far is it to reach our destination, basically? And its metric is the first one we listed, which is hop count. So the routing process for RIP is every 30 seconds exchange a routing table, and the routing table has information about my neighbors. So if a device sees this routing table, it knows that the host that sent it is one hop away, and then everybody that is in its routing table is 2 hops away. So it is able to come up with a representation of the network. How many hops does it take to get to some destination network? And then the packet takes the path with the lowest hop count, which is not always true, but the assumption is that will be the fastest path because it is the shortest. The packet format, I'm not going to have pictures like I normally do because there are many different packet types, and within the packet types there's different codes or commands. So for routing protocols, we're going to point out where they exist in the textbook. Also, it's pretty difficult for us, at home to come up with a packet trace capture that has any or very little routing information in it. So in the main textbook, the TCP/IP guide, pages 614 through 618 cover RIP. RIP was updated to RIP version 2. It was standardized 10 years later in 1998. It is a distance vector protocol like its predecessor. The metric is the same, which is hop count. So what changes did they make in version 2? They actually put subnet mask and gateways in the routing table to make it more efficient. And instead of broadcasting, they switched to using multicasting to send out the routing updates. This is discussed, or at least the packet format is discussed on pages 618 to 620 of your main textbook. The next one we want to talk about is OSPF. OSPF stands for Open Shortest Path First. It came out in 1998 and was updated 10 years later in 2008. First two we looked at were link state, were hop count or distance vector. This one, OSPF, is a link state, and it calculates a link cost that is based on the speed of the connection. That cost, we calculate that, and then we look at the lowest value or the lowest cost and determine where we want to send that packet. OSPF is discussed in pages 639 to 646 of your main textbook. The next one we need to cover is Border Gateway Protocol. It was standardized in 1994. It was improved a few years later in 1998. It is a distance vector. The metrics for BGP are pretty complex. It's based on 13 factors. And the process is choose a path based on those 13 factors. Now, this isn't so much a calculation as like a flow chart. Prefer this over this. If this is true, send the packet out this way. So it's a pretty complex process to talk through. This is covered on pages 664 to 676 of your textbook. EIGRP, Enhanced Interior Gateway Routing Protocol. This was standardized in 1993. It is a combination of a distance vector and a link state protocol. The metrics are bandwidth, load, delay, reliability, and maximum transfer unit or transmission unit. And this is kind of a crazy calculation that is used to determine the route packets make. So there is the maximum calculations with the metrics appearing in that calculation as variables. So this is calculated for each path, and then the process is to take the interface with the lowest metric. So that was a quick discussion on routing protocols.